Alright guys, one of the things that I wanted to do was give you a quick algebra review to help you better understand these questions. Instead of trying to memorize what formulas we need in order to solve each problem based on how we read it, we can try to put it in the frame of mind of algebra. If we can write an equation and just include the missing value in our equation, we can use algebra to solve for x, if you remember. So let's think about it this way. X plus 5 equals 8. Some value plus 5 equals 8. Well, most of us took basic math and we know that 3 plus 5 equals 8. But how do we solve for it in algebra? What we could do is we have to take away this 5 in order to get x by itself. We want to find out x equals blank, right? Because we're trying to solve for x. At the end of the day, we need x equals whatever that question mark will be. How do we get this 0.5 out of here? How do we get this other value that's on the same side of the equals as this x so that x is by itself? We do the opposite. If I have x plus $5 equals $8, and I need to find out what that extra value is, I take away $5, right? So that's all we're going to do. Minus 5. And we have to do it to both sides in order to make sure that the equation remains equal. So if we take 5 away from each side, plus 5 minus 5, if we gave you $5 and took it away, we're at 0, right? They cancel out. So we have x equals 8 minus 5. Or in this case, x equals 3. Now I'm going to move quickly. I'm going to do one or two more, and then we're going to move to the part that's a little bit more difficult. So if we had 2 times x equals 16, I think we can all look at this and say 2 times what number equals 16? Most of us know right off the top of our head that it's 8. But how do we know that through algebra? We know that 2 times the missing value is equal to 16. How do we get this x by itself again? We need to get x equals whatever the answer is. So in order to do this, we have to do the opposite. In the last problem, we had plus 5, x plus 5, and so we subtracted 5 from both sides. In this case, we have x times 2, or 2x. Let's think about it this way. I don't want to confuse anyone. Let's just put it on the other side. X times 2, because it's the same thing. X times 2 equals 16. What we're going to do is we're going to do the opposite of that. We're going to divide by 2. What's 2 divided by 2? 1. So x times 1 is x, right? Anything times 1 is itself. So we divide both sides by 2 and we get x equals 16 divided by 2, or x equals 8. Now here's the part that I want you to, if you're going to memorize something, this is the thing that you should memorize. If you have a value and you are multiplying by a fraction, right? Let's say we have our sales price is $150,000 and we make 6% commission. We want to know what we make in real estate, right? So we're going to need to find out what's 6% of 150,000. Oh, this is easy. All we have to do is multiply it by 6%, right? How do we multiply by a percentage? All we do is we change it to a decimal. Times 0.06 equals, whatever that equals. 150,000 times 0.06 equals 9,000. That's a nice payday, right? So, when we look at a problem and we see that if we need a percentage of the whole, we multiply by the decimal. If we have 200,000 and we make 10% commission, which would be ridiculous, but that would be awesome, we would know that we make $20,000, right? Because we multiply by the decimal, right? Here's where this gets important. For the net closing, which is going to be the first question that we do after this portion of the video, we have a sales price, which we don't know, minus your expenses, equals net closing. Okay? So if the client wants to make $100,000 after all of their expenses, what's the sales price going to be? Well, they're not going to say your expenses are $20,000. Oh, well, that's easy, $20,000, and my sales price is $120,000. That's pretty easy to figure out. They're going to give you a percentage. They're going to say 6% commission, 2% closing costs. So we can add those two together and get 8%. So we need to say sales price minus 8%, or X minus 8%, because this is what we're trying to solve for, equals 100,000. Well, Justin, I don't know. Like, how would I add 8%? Well, what we're going to have to do is we can think about it in terms of a multiplier, right? If we know that we're missing if we know that we need to subtract 8%, what we can rewrite the equation to make it easier. X times 100%, or 0.0. We can multiply it by 1, like that's okay. Minus the 8% that we have. X times 0.08 equals 100,000. In other words, when we first look at X minus 8%, what do we know? We know that the 100,000 is equal to 92% of the sales price. We know that. Realistically, you didn't have to do any of this math, but I'm putting it in this way so that you can understand it algebraically in order to make this easier to solve. So if we know that 92% of our sales price is equal to 100,000, what do we multiply or divide by, right? We divide both sides by 0.92 to get X by itself. Remember how we did that in the previous problem? Now we have 100,000 divided by 0.92 equals 108,695 and some change. Realistically, when you do a listing price, you'd probably list it at least 109,000, right? Because you want to make sure that you get that closing cost. So you could just round it up a little bit, but realistically, this is the answer exactly. Okay. So when we have the net closing problem, which you're going to see in the next portion of the video, here's what I want you to think. If we have X minus any percentage equals any number, let's call it 150,000. Let's say it's 9%. Okay. Remember from our last problem, we need to be able to look at this equation and say, okay, 150,000. What does that equal out of 100%? 100% minus 9 is 91%. So we know that X times 0.91 equals 150,000, right? So then we divide both sides by 0.91 and we get our answer. Okay, let's do it again. X minus 17% equals 150,000. Again, what do we know? X equals 100, so 100 minus 17% is 83%, right? So we have X times 83% equals 150,000. How do we get X by itself? We divide both sides by 0.83. And we get X equals whatever this is, 150,000 divided by 0.83. One last time, because I want to burn it into your brains. X equals 12%. And we want to get 150,000. Okay, what do we know? We know that 100% minus 12% is 88%. So X times 0.88 equals 150,000. How do we get X by itself? That's right. We divide by 0.88 on both sides. All right, that's kind of gross. Sorry. We divide by 0.88 on both sides. We get X equals 150,000 divided by 0.88. When you see that we're solving for a number greater than this and we have the percentage of our expenses given, all we need to do is divide what we know by what we know, right? We know that 150,000 is 88% of the total that we need, right? So all we have to do is we just need to find out what the total that we have is out of 100 and then divide. Okay? That's significantly going to help you. So this problem is called the net closing problem. What we want to do in this problem is find out what the minimum asking price is in order to obtain the given net closing price. So if we want to get $235,000 from the sale after we incur our expenses, we need to know what the price that we should ask for is, or at least the minimum in order to get the $235,000 that we want to get from this sale. The first thing we're going to do is we're going to add these two percentages together to know the total amount, the total cost incurred before the profit that we want to see. So that means we have 8% of commission and closing costs. We just add them together to get 8%. If we think about this in a basic algebraic way, you might think of it as x minus 8% equals $235,000. This is what we already know. Now you might be thinking this is hard. I didn't do algebra with percentages before, but let's not think of it. Let's not make this harder than it has to be. What we know is that x is going to equal 100% of the price that we need, right? So we have 100% minus 8% equals 235,000, which means 100 minus 8, 92% of our asking price is going to equal $235,000. Now, in order to figure this out algebraically, we have x times 0.92 equals $235,000. The reason is because in order to find out what the percentage of x is, we have to multiply by the decimal. And from here is just simple algebra. We divide both sides by 0.92. And now the rest is easy. X equals 235,000 divided by 0.92, which plug that into your calculator, and you're going to get 255,435. That's going to be your minimum asking price in order to obtain 235,000. So once again, we knew that we had 8% of costs incurred. And we know that the other portion, the portion that we want to come away with is 92% of the total asking price. So we just multiplied 0.92 times x, and we get 235,000. Again, we divide both sides by 0.92 to isolate x so it's on its own. Now we know that the answer to x is 235,000 times divided by 0.92, and we get $255,435. That's your minimum asking price in order to get $235,000 after your closing costs. In this problem, we're going to try to find out what the monthly tax liability is. In other words, what are we looking to pay per month in taxes? So whenever you're calculating this, you should have all of the information that's on here provided in your question. In this case, we have a market value of $150,000. We have an assessment rate of 15%, an equalization factor of 1.4%, and a tax rate of 50 mils. So let's go ahead and get started. To find out what your assessment, you should be familiar with all these terms. The assessment rate is the rate at which your tax liability is determined by your taxing authority. So all we have to do is just figure out we're taxed at 15% of 150,000. Well, that's pretty easy. 150,000 times 15%, which is 0.15 for our purposes. If you plug that into your calculator, you're going to get 22,500. Okay, so we're getting there. We have 22,500. But we have an equalization factor. If you remember from your text, the equalization factor is what's used either in your neighborhood or for your property specifically in order to make the tax rates equal based on the services that are provided in your jurisdiction. It's just a way to make sure that everyone pays their fair share of taxes based on the services that they are provided. In this case, we multiply the assessed value, which is $22,500, by our equalization factor, 1.4, which gives you $31,500. Now your tax rate, again, we need to remember what mils is. 1 mil equals 0.001. This is what our tax rate is going to be. So they take this number that they calculated to be our assessed value multiplied by your equalization factor. So this is the amount that we're being taxed on. Okay, this is the amount that the government is working with. So, and then they're going to take that and they're going to multiply it by the 50 mils. So if 1 mil equals 0.001, well, 50 mils equals 0.050 or 0.05. So that's pretty easy. At this point, we're just going to take 31,500 times our 50 mils, times our 50 mils, or 0.05, and we're going to find out that our annual, not our monthly, our annual tax liability is $1,575. And then from there, we just divide by 12 in order to get our monthly tax liability, which would be $131.25. Make that a little bit better. So from start to finish, we have our market value of $150,000. We multiply. This is going to be all multiplication up until we get down to this last part. Multiply, 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 divide. Pretty simple. If you don't have your equalization factor, it'll just be multiply, multiply, divide. But you don't have to remember the steps. Just think about it logically. We have our total value that the property is worth. We multiply it by our assessment rate. This is what the government is assessing our tax liability at, $22,500. Then we take that liability and we multiply it by the equalization factor to get our total tax liability for the property. Then we multiply that by the tax rate of 50 mils or 0.05. And we get, I'm sorry, I didn't put it here. We get $1,575. We multiply that number, or we divide that number by 12 because there's 12 months in a year to get our monthly tax liability of $131.25. So in this problem, we're trying to calculate the depreciation. If you go to chapter 19, the appraisal chapter, in the back of the chapter, there's a chapter quiz. This is going to be question 17 if you want to follow along in the book. So the question asks, a building, or it says a building was purchased 5 years ago at $240,000. It currently has an estimated remaining life of 60 years. What is the property's total depreciation to date? So in this question, what we're trying to find out is if we bought the property 5 years ago at $240,000 and we have the estimated remaining life of 60 years, how much has the property depreciated from this $240,000 since the building was purchased 5 years ago? In order to find this, what we first have to do is find out what was the total number of years that the estimated life was when we first bought the building. And that's pretty simple. 60 plus 5 is 65. The reason why we do this is because in order to calculate depreciation, what we're going to do is we're going to take we're going to take the percentage of 1 over the number of years per year in order to find the depreciated value. So in this case, 5 years later, let me make this a little bit more clear. To calculate the depreciation, we have 1 over the number of total years, 65, times the number of years since the purchase, which is 5. So that means we have 1 over 65 times 5 over 1 equals 5 over 65. Right? So this is our depreciation factor for this problem. I'm going to go ahead and rewrite it right here. So to calculate the total depreciation for this property, we're going to multiply 240,000 times 5 over 65, which is our depreciation factor, to get our total. Which, depending on the calculator you use, you might want to calculate this number first. 5 over 65 is going to give you something like 0.0769. Now, I tried rounding it up to 0.08 and got a number that I don't think matched the correct answer that's listed in the book. I rounded it down to 0.07, and I didn't get a very close number either. I put 0.77, and I got pretty close. But what I realized is maybe to go out to as many decimals as you possibly can. In most calculators, if you typed in 5 divided by 65, hit enter, and then multiplied that number by 240,000, it will be able to use the long decimal that comes from this first fraction, and it will be able to use that whole thing and multiply it by 240,000. If you happen to have a calculator where you can multiply this number by the fraction, you'll get the exact answer of $18,462. You check the back of the book, C is the answer. Once again, what we had to do was find out the total number of years for the estimated remaining life from the day that we bought the property 5 years ago. So we add the age of the property plus the number of years left to get that total number. Then we took 1 over 65 times the number of years that we have right now to get that 5 over 65 number. Again, that's that decimal, 0.0769. We multiplied this number right here. We multiplied this fraction by 240,000 to get our x, or 18,462, which is C. One of the last things that I wanted to show you in this video is how to read a legal or calculate the size of a lot for a legal description. One of the things that you might want to memorize, this is on page 161 in your text. This is in chapter 9 under legal descriptions. There's a much better graphic breakdown of how large each plot size is, but it's good to know that the total size of this entire lot is the total size of this entire amount, I should say, is 640 acres. So we know that 1/4 of 640 is 160, right? 1/8 is 80, and so on down the line. As you can see, if you would remember that 1/4 is 60 and you're able to break it down based on the fractions that are given to you, you'll be able to find out what the size is. Okay. If we had a legal description as seen above, but there are two ways you can approach this question. The first is to try to map it out on your quadrant right here, okay? Again, we know that the total for the whole thing is 640 acres. Okay? So let's try to start. We have the north half of the northeast quarter of the southwest quarter. What I like to do is start backwards and move this way. Southwest quarter, that's down here. The northeast quarter of the southwest quarter. Okay, so we know that the southwest quarter we're dealing right here explicitly. Then we have the northeast quarter, okay? So we know it's going to be somewhere here, right? It's going to be somewhere in here. The north half of the northeast quarter of the southwest quarter. The north half of the northeast quarter of the southwest quarter. We know that that's accounted for. And always think of this as an addition. And if I had $2 and you had $5, together we have $7, right? And equals plus. Try to get that in your head. So this is one portion, and we have the second portion. The southwest quarter of the northwest quarter. Remember, go backwards. Northwest quarter, we're dealing with this quadrant right here. The southwest quarter. Draw quarters into this quarter, inside the quarter. Okay? If the whole is 640, we know that 1/4 is 160, okay? We don't have 160. As you can see, an entire quarter is not filled out, but bear with me. 1/4 of a quarter is 40, okay? So here, this portion right here is 40 acres, right? Because we have 1/4 of a quarter of the whole, okay? Plus this smaller lot here, which is 1/2 of a quarter of a quarter, right? 1/2 of a quarter of a quarter, quarter of a quarter. All right, if 1/4 of a quarter is 40, what's 1/2 of a quarter of a quarter? That would be 20. I'm going to put it up here. Okay? Again, 1/4 of a quarter of 640. Here's 1/4. 1/4 of that quarter is 40. 1/2 of this, remember, right here, is 20. 40 plus 20 is 60 acres. Okay? So that's one way to solve it. You can draw it out. There's nothing wrong with that. You just got to make sure you're drawing in the correct quadrants and that you're drawing the right size lots. How else can we figure this out? Algebra, you guessed it. 1/2 times 1/4 times 1/4 plus 1/4 times 1/4 times the whole, 640. Okay? Remember from the earlier video, if we have a percentage of the whole, we multiply the decimal or a fraction, which is the same thing. Like if we had 25% of the whole, we multiply x times 0.25. It would be the same thing if we had 1/4 times x, which would be the same thing as 0.25 times x, right? It's the same thing. What we need to find out is what this fraction equals, and add them together, and then multiply by the total, 640, because we need to find out a percentage. All of this is equal to a percentage of 640, okay? All right. The reason why I put it in parentheses is just to separate it. So we need to answer these problems first, and then we need to do one parentheses at a time. Okay? If you remember from math, we can do, when we're solving for this one down here, we just multiply across. Two times 4 equals 32. 2 times 4 is 8. 8 times 4 is 32. 1 times 1 times 1 is 1. Okay? So we know that this side up here is equal to 1/32. Bear with me, I'll rewrite it. Okay? I'm going to separate it right here. 1/4 times 1/4, multiply straight across. 1 times 1 is 1, 4 times 4 is 4, and we have 1/32 plus 1/16. Okay? Also, if you remember from math, when we add fractions, to make it easier, we need to make the denominators equal. So we know that 1/16 is the same thing as 2/32, right? 16 is half of 32. So if 16 is half of 32, 2/32 is equal to 1/16. It's the same thing. Okay? So what we can do is 1/32 plus 2/32, okay? Once again, bear with me. We know that this portion right here is 1/32 plus, because we have the addition sign here, 1/16 or 2/32 equals 3/32 times, don't forget that last part, 640, which I will bet you anything that it's 60. If you don't have a calculator that can do this fraction here, what you can do is 300. You could do 640 divided by 32, and then multiply that by 3. So 640 divided by 32 is 20 times 3, because we have the 3 up here, equals 60, which is the same thing as what we had before with 20 and 40 added together to get 60. Okay? Let's take it. Let's go back and do the math one more time. Okay? We have half of a quarter of a quarter. When you see the of, think multiply. 1/2 of 1/4. Oops, 1/4, I'm sorry. Of 1/4. That's one portion. Plus, because we have the and here, 1/4 of, which is multiply again, 1/4 times 640. We always have to do this. Always, always, always. When we're trying to find the size of a lot given the legal description, the last thing that you're going to have to do, and I hope you don't forget this, is to multiply by 640, because we have to take, if we're taking a part of the whole, we have to multiply the part by the whole. Okay? So again, 2 times 4 is 8. 4 times 4 is 32. 1 times 1 times 1 is 1. Plus 1/4 plus 1/4, which is the same as 1/16. Okay? Again, to make it easier, we want to get the denominators. We want to get the denominators to match. In order to get in order to turn 16 into 32, we multiply both the top and the bottom by 2 to get 2/32. Remember that, okay? 2/32. And that equals a total of 3/32. Pardon my writing. 3/32 times 640. Again, if you don't have a calculator that can do this and then multiply it by 640, you can just do 640 divided by the denominator, 32, which is 20, and you got to multiply that by the remaining numerator up here. 20 times 3 equals 60. So you can either do it by drawing it out like we saw before, or we can just take all of the fractions Anything that has an of, we know that it's fraction, multiply, fraction, multiply. And then we have the and, okay? We have the and, which means we have to add that first portion to the second portion, fraction, multiply, fraction. So we have this set of fractions, this set of fractions. We add them together to get this total 3 out of 32. Multiply that fraction by 640, and we get our answer of 60.